Hello there, it's Jay here from Jay's Vintage Junk, and today we're back on with the Commodore C16. And what I thought I'd do, I've been fiddling about with this off and on for the last few days, and I'm not making that much progress. It will fire up. I even got it to start loading a tape game. I managed to dig out a data set for it. Where is it? It's here. I managed to actually find one of the cassette correct data sets. I thought I might have one left at least, and this one's in really nice condition. It just needs a clean. But I did try loading a game. It got so far and then stopped loading. It could be a bad cassette, it could be a bad drive, but at least it shows that something's working on it. But we're still down to that it's very reluctant to start up. You can switch it off and on perhaps 20 times, and in that 20 it might start once or twice. There is possibilities it could be something logic related, but something's drawing me basically now to should I recap it basically and take it from there, because we don't know the state of any of these electrolytic caps, and they're 34-year-old. Like in the old speckies, they're not going to be in the best of conditions. Fortunately for one of these, it's not like the early 48K Spectrums. A faulty capacitor can't literally kill the board and kill big parts of the board, like the RAM and stuff. It'll just stop it working or make it intermittent. Like if one of these is to do with timing and it's malfunctioning, that could be the problem we're having. It's not like resetting a timing loop or something like that, or indeed it could just be noise somewhere that's interfering with one of the reset lines or something like that. So I think until we actually replace these capacitors, we're going to be stabbing things in the dark. So I thought that's what we'd do in this video today, and then we'll go over the next steps. When we'll change them capacitors, we'll populate this board up again. We'll give it a try, see if it's made any improvement. If not, I'll go into what I'll look at next, because I've had some good suggestions off people in the comments section. So we'll go into a few other things that we'll look at next. So anyway, without further ado, we might as well get on with this recap. We'll start here. We've got, let's just whip it out the board. We know negatives that way. I can probably see it better when I've got it off the board. Got most of it. And this one could be a bugger because it's on a right big ground plane on the other side. Just a little bit of fresh solder to that. See if we can help it flow a bit. Try getting that out now. Give it a quick touch that way, it's nearly out. We may just have to rock this one out. I think it'll come out fairly easily. Come on, out you come. There's a great big ground plane on the other side here. It's making this side a bit tricky to get out. I think I might need the bigger soldering iron to get that out. Let's switch on the big one. In fact, is that plugged in? No, it's not even plugged in, is it? can't even spot the lead. Ah, there's the lead for it. Oops. Just bear with me a sec while I plug this in. There we go. Not throwing you off too far, is it? No. Switch that on and get that heating up. Might move on to the last one. So yeah, let's move on to that one while we wait for that bigger iron to heat up. Nearly free. And do a little bit more work on that. Hopefully that's got it. Right, the other side. That side's free. Just this side. Like, so there's a bit of a ground plane on here, and it's with this small iron, it's struggling a little bit. There we go. It's nearly out, that one now. Really, it's been a bit of a pain, that. Let's try having a little bit of fresh solder. I can smell a hint of bag capacitor in the air. Not very strong, I must admit, it's not very strong, but I can smell it. It's not that really acrid smell, it's just a slight whiff of slightly off electrolyte. Let's try that now. What's that side out? That's the first capacitor out, and it is 10 UF at 25 volts, so that's an easy one to get a replacement for. Let's see if we can just clean the holes up. There we go. It's got them clean. Let's see if we've got a 10 UF at 25 volts. I've got some 10 UF in here. Got the 10 UF at 35 volts, that'll be absolutely fine. What goes in that way? Okay. Let's get my little big box. There we go. That's the first one changed. Let's see if we can get that little bugger. Ah, my other iron should be heated up now, so let's have another go at getting that out. It's a bit of a beast of an iron for doing PCBs really, but at least it should attack this ground plane easy enough. Even this is struggling a bit. So out from that side. See if we can get in there. It's right on this big ground plane, that's why it's such a pain to get out. Could even conceivably just pull that off the board and then deal with the legs. That leg's just snapped, so that's that idea decided. Oops. Let's just get this capacitor out of the board and then we can deal with that snapped off leg. There we go. That's that one out of the board. There's no damage there. It's just this is what's the pain in the backside. If you let me just zoom you in. Oops. Move you over here. You can see where we're working here. If you look, all this here is ground plane. So when you try to get that leg out there, basically all your heat's being sucked away by all this metal here. That's why that particular leg there is being such a pain to get out. Now we've actually got that the actual capacitor out of the way, it might be a bit easier. I'm going to add a bit of fresh solder to it from this side, and then I'll have a go at sucking it out this way. So it's not the most ideal of irons, this really, but at least it's got a bigger thermal mass than my my little Antex I'm using. It is being a right pain in the whatnot, this actually. Try getting it from the other side. At least we've brought a lot of that leg through. I can see it here. So let's still sticking in there stubbornly. Let some nice fresh clean solder do its work. See if that'll help. Really is being very, very stubborn. Let's try getting this side again. Now these boards are horrible. I have just spotted a little cheat that I might be able to do. Basically there's an unused hole right next to it. If I can suck that clear, I can just slide, it's only the ground side, it doesn't matter, it's here. In fact, let's try the other iron. If worst comes to it, we can always really cheat and just drill a new hole. See, it's just so thick, this ground plane here, it's being a real pain. It's just not allowing the solder to come off the board. Nearly got it then. I think we've got one. That was a right pain in the backside. Let's just have a quick look under. Yeah, there we go. I managed that. Now we need to unblock the next one there. Hopefully this one will be a little bit easier. There we go. Nice and easy, that one. And the capacitor is 1 UF at 50 volts. So I'm sure I've got some 1 UF at 50 volts. Yes, I have. One UF at 50 volts. Just snip that bit of leg off there that's sticking out and causing it right. There we go. Yeah, I know it means that it doesn't quite sit within its little mask on the PCB, but it's in the right place electronically, so that's all that matters. And I'll do less damage doing it that way than I would if I kept trying to get that bit of leg out of that hole. It's all down to that ground plane that's there. It really is that much of a heat sink. It's a real challenge. Okay, there we go. Knocked on me. Bits of cut off wire all over my table. Damn. Just bear with me a second, folks. I've got to pick all these up or they go everywhere. And they are incredibly useful when you just need to bridge that little connection. There we go, they're all back in their home. Right, let's cut that last one off there. I'll zoom you back out. Right, there we go. Let's have a look at the next one. Hopefully it's not going to be as much of a pain as that one was. There we are, it's in home. Let's have a go at this one over here. Or I should really have a go. Those are probably more critical, I think, because the CPU and TED, they're on their lines, I think. Oh, we've only got what, 6 more to go, and the whole board's got new electrolytics on it. So let's do this one. That is that component there. Yeah. There we go. That one was a bit easier. We've got another 10 UF at 25 volts. I'll have to order some more of them. We've not got that many left. Okay, that was an easy one. And this next one here, same value. Let's just see where it is again. It's this one here. And they're not so much of a hassle to get out when they've no massive ground plane on them. That should come out. Let's give it a little bit of a tweak. There we are, that's out. Again, 25 volts, 10 UF. Oops. There we go. I think I nudged that one slightly, so hopefully it's not too on the skew. Let's have a look. Obviously there's a little bit, but that's good enough for me. Now let's do that one next. This one's a little bit tricky to spot on the board. And it's there. That one there. Okay, it just needs a little bit of extra persuasion. Let's try just another quick suck on this side. There we go, that's right. Pull them out. That side's just being a little bit more stubborn. There we go. Oops. I'm going to say that one was really 25 volt 10 UF. Hopefully I've got enough to finish this board. I don't think we'll be recapping any of the other ones until I get some more capacitors ordered though. And the positive side is that side, so that way on. Like that. Push it home. There we go. That's that one done. We've got them two to go, and then that one over there. So let's see what this one is. Oh, well, do you have any? No, it's another 10 UF at 25 volts. So they're getting a tiny bit of an upgrade because I'm using 35 volt to replace them, but so that doesn't matter in the slightest. This is another one that's going to be a bit of a pain because there's a huge ground plane. And I've got that side. Let's have a look. Try going with the bigger iron. So it's not ideal this really, but sometimes you need that little bit of extra thermal mass, especially when the buggers like these. So go see if that's done it. No, I think we're going to have to use the other technique and just heat it and walk it out. That's that side for 8. What's that? Then there we go, it's out. Probably have a little bit of, oops, you didn't see much of that, did you? Sorry about that. Yeah, we're going to have a little bit of, oh, I don't know. Oh, well, one hole's clear, one hole isn't, so that's not too bad. Yeah, 25 volt 10 UF, another of them. Let's get the hole cleaned out first though. Hopefully we can do it with this. They do like the large ground planes and power planes in these C16s, I'll say that. That gets us, let's hold it up to the light and see. Nope. Alright, so it's that side that's still blocked. We can't do what we did on the other one and find a hole next to it which we can get in, so we are going to have to make this work. Let's get the big iron back in. That gets it. There is a hole through there, but it's not exactly large. It's still got a little bit of solder in it. Hopefully it's going to be big enough to get the leg through. Especially considering these modern capacitors are much smaller than the older ones, and the legs seem to be thinner as well, so let's hopefully we can get away with it. We'll see. If not, we'll have to do a bit more sucking. There we go. Managed it. That side done. That side done. So we've just got two left to go, that one and then that one. Let's get this one out first. That's an easy one to spot, and hopefully it's not going to be too bad to get out. Again, this one's got a right big ground plane on it. It's going to be a right pain in the whatnot to get out. Let's try walking it out with the other iron again. So many times it's a lot easier to clean the hole up once you've actually got the component legs out, so especially if it's only a 2 or 3 legged component, this can be the easiest way of doing it. It's one side out. Second line one out. Nearly 10 UF at 25 volts. And again, I will say there's ever such a slight whiff of electrolyte in the air. And there does seem to be a little bit of something on the leg on that one as well. Right, let's see what we can do with these holes. Oh, I think we may have struck lucky on this one. That side there, possibly we can just do with a quick sucking. There we go. Let's get fortunately we had enough. I've got one left after this. Hopefully I don't need it for the other one. I think that's bigger. I think that's something like a 220. Let's stick this in here. There we go. There we are. Got one more to go. They look okay. Just change that one there. It's only smoothing that on the 7805, so it's 47 UF at 16 volts. I would have expected slightly bigger actually. I'm going to regret trying to change this one. That ground plane is huge. Let's get the bigger iron in then. Move my wire so I don't burn it. And where was I there? And my iron's gone to sleep. It's the only problem with this iron, it does have a tendency to go to sleep on you. Let's get it. There we go, it's back up to temp now. Let's try that again. So that side out. It's the ground plane on this side that's the problem. It's massive. I mean, it's a right struggle to get this thing to release. So the other side's pretty much out, it's just this side. Just isn't for melting. Let's try adding a big load of solder there, see if we can get some thermal conductivity, see if that'll help. Because we can always suck it off after. There we are. In fact, oh, come out, you little sod. I'm going to break the capacitor off and then deal with the leg. That might be the course of action I have to take. Give it one last go, try to pull it out. I've got that side out. Now I've just got to deal with this top one. is not wanting to desolder for some reason. The other side's out. So it's got massive thermal mass both top and bottom. I wonder if I get the iron. So this iron really is a bit too big for this. I wonder if I get the iron in this side and see if I can get the solder to melt. Let's get hold of it with these. That solder is not for melting. There we are. That should help. Bloody hell. There we are. Now that was a bugger of a capacitor to remove. And of course that's now left us with the problem of we need to clear the hole out, but at least we got the bloody thing out of there. I've not done any damage, no. I'll just clean the tip off on this. That's one hole cleared. I know this one's going to be a right pain in the bum to do. Nearly there. I can see literally a pit down there. It's just that last little bit that's going to be the pain in the whatnot. I may actually have to take my PCB drill because we're heating it up so much to try and clear the hole there. I'm actually starting to lift the trace. I lift the whole ground plane around it. It's generating too much heat. So what I think I might have to do is just get my PCB drill out and just drill a new hole next to it to take that. That's probably what I'm going to have to do, to be fair. They're not the easiest board to work on these. They're certainly not a board I'd recommend to a complete beginner, a complete novice anyway. We'll give it one last go and then I'll resort to having to dig the old PCB drill out and drill a hole in it. So the other hole's cleared easily enough, it's just this one. No, it's not clearing that at all. It's just sucking all the heat away from where I want to suck the solder out. I'm just doing more damage than good doing that. So like I said, what I'll do is I'll get the old PCB drill out and I'll just whip a new hole in there. I think I can get it out while you're on the stand. Yeah. Perhaps a little on the large side, but I'm sure it will do. Plug it in. There we go. Let's clean the other hole out while I'm here. There we go. Perfect that. Right, now what was that capacitor? Let's get them out of the way for a second. It was 47 UF at 16 volts. I'll have something suitable, yeah. Slightly higher voltage rating, but that shouldn't matter. But 47 at 50 volts here. Put that in there. I will use the big iron seeing these ground planes are such a problem. There we go. It's a bit overkill, that iron, for doing things like that, but we need good penetration, it does work. Okay. Move my solder, can get them away. Alright, let's have a look at that now. Clean this dross off my top. Right, there we go, that's all the capacitors. I'm not happy with that. That side's fine, the solder hasn't even flowed through properly. We're just going to touch it up on this side, just make it look a little better. Just on this, again it's that ground plane. Absolute nightmare in these ground planes. There we go, that's better. Just make sure there's nowhere else that's happened. I think all the rest are absolutely fine. Yeah, all the rest are good. We've managed, in fact, that one, even that one there, I'm just going to redo that one as well. So it's something you've got to be really careful, especially if you're using a low powered iron. And those big ground planes is are you getting good penetration right the way through the board. It's a double plane board like this. That's better. That's got it. I'm happy with that now. Right, let's get this thing repopulated and we'll see if it's made any difference. Where's my... Here it is. I've got my board. I've got all the chips on because it's another board I was trying, but I've had no luck with this one either. So the aim of all of this is basically to get one working board, and then we can you go very further back? Yeah, a little bit. Then we can take it from there. Like I said, once we get one board that we're happy and it's stable and it's definitely working, it makes it a lot easier for us to get the other, or at least a couple of the other boards working. So we've got a good reference then. At the moment we're playing pretty much blind. Turn pin sockets are not, I mean they're brilliant turn pin sockets, but they're not ideal for chips that have been in a board unless you can guarantee you've got every single bit of solder off the legs, so they're a right pain to get in. Oh, well, I need to pinch the fuse as well. Right, let's put that one to one side and let's get this powered up. I've made a new cable up, which is actually correct now. This is C64 composite and audio. I've not got SVID or anything connected up on this, literally just computer and audio, but it is correctly wired for the C64. It does fit in the back of here properly. Right, where's my power supply? Well, I'm still using, I have checked the voltages with a working meter on the C16 supply, and it is, crap. That's what happens when you pile too much things up on your workbench. You get a cascade every now and again. Fortunately it was only Falco bit the dust. Plug that in here. The reason I'm using that spec of the supply is because it's the closest to 9 volts that I've got that is wired correctly. So I will, once I've done that, I will dig the proper C16 supply out at some point and we'll start using that. Right, let's get the TVs on AV and get you up there. You don't want to see that in your shop, do you? Let's move that. Right, switch on, let's see what happens. Probably nothing, we'll probably get the black screen like we have. Yep, that doesn't seem to have made any difference at all. But hopefully we'll give it a few tries, see if we can actually get it to... Don't worry about that artifact, that's my monitor. So if you do keep doing this, it will eventually seem to spark into life. There we, oh well, not quite, but it's nearly there. Let's try that again. Again, that's not happy. These are some new symptoms I've not seen before. Could that be playing up PLA maybe? Let's try it again. Or bad RAM. Certainly we've had a change in behaviour. Oh, and we're back to this. Right, there's definitely something wrong there. Even because, I mean, when it was firing up before, it was firing up correctly. We didn't have these issues before. That's not good. You see that changing on the screen there? That's me just rubbing my finger over the top of the TED chip, doing that. I hope the TED hasn't decided that it's playing up now, but that literally is me. If you look, that is me just doing that with my finger on the TED chip. Is causing, if you look that on the screen, it's causing them lines to move. You come there, and if I, you see, that's not good. I will just quickly try changing them ROMs, because I didn't actually change them ROMs before. I think all these ROM sets work. I think I have ascertained that they work, but just to be on the safe side, let's just swap these ROMs out, see if that makes it come back. If not, we may have even more issues. Let's try that one first, see if that makes any difference at all. We'll have to play this game of switching off and on again and see if it'll actually fire up. That's the other problem. I think it's definitely not behaving now. It'll do this, and then you leave it, you come back to it the next day and it fires up. So ignore that, that's just the monitor. It doesn't seem to be wanting to fire up at all now. No, that's a bit of a pain. Nope. Try swapping that chip back. The IC socket on the other board that I've borrowed this chip off is absolutely knackered, so that's definitely something that we'll need doing. Hardly even holds the chip at all. Very, very worn. Nope, this doesn't look good, does it? And these chips were firing up when I played with them in this board a few days ago. So it doesn't even seem to be getting that far now, unfortunately. One last try. Nope. Well, looks like we've got even more issues. Now, what some people have said, like I said, I've had some rather good comments from people in my in the comments on these videos, and someone I believe said try U7 and U8, which are 74LS 257s. So that's that IC there and that IC there. Apparently they're quite common for failing, and when they do, they give black screen symptoms like we're getting. So I think what I will do is I'm going to pull them two ICs out, and because they're standard 74 series, I can test them using my Speedmaster. So I don't even have to pull some off another board or anything like that. I can literally just test them in the Speedmaster. And if any of either of them are faulty, I'll have a hunt through my spares and see if I've got any replacements for them. It could be that they're getting glitchy, they're intermittent, and they're not behaving. But that new symptoms does concern me slightly, because I said before, it was, apart from the fact it was very random on starting up, and like I said, perhaps once or twice in 20 attempts it would fire up. When it did fire up, it was actually at least to some extent usable. Like I say, I had the keyboard and the tape drive connected, and it was attempting to at least load some software. But now it looks like we're not getting anything apart from a black screen again. So something has definitely gone awry. I really do hope it's not the TED or the CPU which have decided to fail on us. So the only other thing is it started doing this since we recapped it, but I can't see at all where I've gone wrong. I've not put a cap in the wrong way round or anything. Let's just double check that. No, definitely not. All the caps are definitely in the right orientation. They're all the right values. So that is really a bit of a mystery. Why has it suddenly started doing this when it should theoretically be behaving more? That it's got nice fresh new electrolytic capacitors in it. I do just keep trying it just to see whether I can get it to do like it did before. And well, it's fired back up to this. So it's come back on, but it's fired back up to that. Yeah, and like I said, that's affected by me putting my hand on top of the TED. And being that the TED generates the video, that's why I'm a little bit concerned. Has something possibly happened? See, I can touch the top of all the other ICs, even the CPU. Nothing. As soon as I touch the top of the TED, you can see that moving on the screen, can't you? So that literally, that's me just rubbing my finger over the top of the TED. Nothing else at all touching it. Anything else at all seems to affect anything. Just that. I wonder if we just quickly try the other PLA. Just bear with me a second. I think I've got it over here. Where is it now? Where is it? Sure, I put it on a piece of this. 25161. Ah, there it is. I'll stick this other PLA in. I think really what I do need to do is take out that U7 and U8 and test them properly and see whether that makes any difference. Right, let's try that. Again, it's just not starting up, is it? Until we can get that not starting up issue solved, we can't really solve the other that graphical issue that it suddenly developed. So it seems to be always the way with these old computers, especially like I said, these ones, which I know they've been looked at before. It was a very long time ago, and there's obviously a reason why I didn't bother going much further with the repairs on them. it's definitely misbehaving. It's not starting up regularly. It's probably not doing it a heap of good just keep switching it off and on like this, but no, I'm going to call it there. So unfortunately, like I said, we don't seem like we've made much progress. But on the plus side, at least we've got a board which is now fully capped. We'll have to wait to order some more 10UF capacitors though, because doing this board's pretty much cleaned me out. So yeah, I'm going to leave it there for now. So in the next video I think we're going to be removing U7, U8, and someone actually mentioned U9 as well. Remember when I did have it work and it wouldn't work on the SD to IEC? Someone else, I think it might be the same guy actually, mentioned U9 maybe the problem for that. So I think, like I said, what we'll do is we'll pull U7, U8, U9 out in the next video. They are all 74 series, standard 74 series logic. So this U7 and U8 are 74 LS 257s, and U9 is a 74. I think it's 7406. Yes, 7406. So the standard parts. I believe they do actually have MOS part numbers as well. I think they're one of these parts that MOS Technologies basically made their own and put their own part number on it. But it is just a standard 74 series logic gate. So that's what we'll be doing in the next video on this. So unfortunately, it was a shame that recapping it didn't fix it, but at least it's recapped now. So join me in the next part. I hope you enjoyed that. So thanks for watching and goodbye.